Welcome to the deep dive. Today, we're really getting into Alephium. It's a layer one blockchain that's, well, it's making some waves trying to solve those big crypto challenges,
Mm.
scalability, security, and, sustainability. We've gone through quite a bit of material on this, and it paints a really interesting picture of what they're trying to do. So our mission here is basically to unpack Alephium's core ideas, its innovations, the whole ecosystem, really. Give you a shortcut to understanding why it's standing out.
Yeah, and for you listening, getting a handle on these layer ones is just so important. They're the foundation, right? The infrastructure for everything else in digital assets, all the dApps, new economic models. And Alephium is interesting because it's really trying to combine the best bits from models we already know, learning from what came before.
Right. Okay, so let's start at the beginning. What is Alephium, fundamentally? At its heart, it's a sharded layer one. It's got this custom virtual machine built for all sorts of smart contract uses. And the thing that jumps out right away is the security angle. They claim it directly gets rid of risks like reentrancy attacks and those two-step unlimited approvals.
Which, if you think about it, is huge. I
Yeah.
mean, those two attack types, they've cost billions on other chains. So if Alephium tackles those right at the base level in the architecture itself, well, that makes smart contracts inherently safer from the get-go. And then there's the performance side. They're talking, theoretically, over 10,000 transactions per second. That's thanks to their own sharding algorithm. Plus, that unique proof of less work model we should dig into. It's about improving on Bitcoin's energy use, making it greener by burning tokens.
Okay, 10,000 TPS and better energy efficiency. That's definitely ambitious. So how long has this been cooking? When did Alephium actually, appear on the scene?
Well, it's not brand new. The white paper came out back in February 2019. Then they had a test net in December 2020, and the mainnet went live in November 2021. And since then, the growth has been pretty impressive, honestly. Our sources show a total value locked, the TVL, around $14.14 million on chain. There are over 50 active projects running on it, and get this, more than 305,000 active addresses.
Wow, over 300,000 addresses already. That's significant adoption for a relatively young chain.
It really is, and you see that reflected in the network security, too. The hash rate, it shot up over 25 times in just 6 months, hitting 50 petahashes per second. That tells you more people are participating, securing the network. And this isn't just numbers. It leads to real applications, like they've partnered with gigatons,
Yeah, I saw that.
right, to tokenize carbon credits. They're using Alephium's security and programmability for these high-value assets to, help fight climate change. It really shows the potential impact.
That Gigatons partnership does make it very concrete.
Hmm.
Okay, so we've heard the claims, security, scaling, sustainability. Now, how does it actually work? Let's lift the hood, see what makes it tick technically.
Exactly. Let's get into the nuts and bolts. One of the absolute core pieces is their stateful UTXO model. They call it SUTXO. It's really a hybrid. It takes Bitcoin's UTXO model, which is great for just moving assets around simply, securely, transparently, and merges it with Ethereum's account model, which is, better for smart contracts that need to track state, more like a database.
Interesting. So like Bitcoin security for transactions, but with Ethereum's smart contract smarts. That sounds potentially very powerful for a layer one.
It is, because with SUTXO, things like creating new tokens, sending them, keeping track of them, it's all built in natively, like the ALPH token itself. This gets around Bitcoin's limits on tokens, and it also means you don't need separate standards like ERC20 or ERC721 like on Ethereum. Which, by the way, cuts down on security risks tied to those complex standards. And the stateful part is crucial. That's what lets you build complex dApps that need to remember things, that need state to function securely.
Okay, so that model needs the right engine to run it. That brings us to the virtual machine and the language, right? How do they connect to UTXO?
Precisely. The SUTXO model is powered by the Alephium Virtual Machine, or Alfred. Think of it as the brain, the computational engine for the dApps and contracts. It's specifically built for SUTXO and written in Scala. And then developers write the contracts using Ralph. That's the smart contract language for Alfred. They designed it to be pretty high level, easy to read, quite straightforward. Took some inspiration from Rust, which helps developers pick it up faster.
Right, and I heard there's some key differences, improvements maybe, compared to the Ethereum virtual machine, the EVM, which is everywhere. Where does Alfred really stand out?
Yeah, there are several key areas, especially around user experience and, again, security. So for user experience, Alfred gets rid of that often confusing step where users have to approve token spending separately, like you do in EVM.
Oh, that infinite approval thing people accidentally click.
Exactly that. With Alfred, permissions are set right in the contract's function. This cuts down on human error, stops people accidentally giving contracts unlimited access to their tokens. Then there's MEV attacks, maximal extractable value. Alephium's transaction flow, the input-output thing, makes complex MEV attacks much harder. An attacker would need several transactions in a row, which is riskier and less likely to happen.
Okay, so it makes it tougher for bots or miners to extract value unfairly. What about things like flash loans? Those have caused some major headaches.
Right. The UTXO part of SUTXO really inhibits flash loans because an output, basically the result of a transaction, can't be spent until the transaction creating it is confirmed across the network. You can't borrow and repay in the same transaction block. That whole exploit vector is largely shut down. And maybe the biggest one, reentrancy attacks. The SUTXO model makes them fundamentally impossible.
Impossible. That's a strong word.
Well, functionally impossible because an output has to be validated before it can be used again as an input. It's built into the model. Compare that to Ethereum, where billions have been lost because contracts could be tricked into calling themselves repeatedly. On top of that, Alfred has built-in safeguards against common coding errors, and this asset permission system, APS, adds another layer of checks for token transactions. It's really security from the ground up.
Okay, that's a very comprehensive security picture. But the other big piece is scale. How does Alephium handle, lots and lots of transactions? That 10,000 TPS claim.
Yeah, that comes down to sharding and their specific algorithm called block flow. Sharding basically is splitting the work, dividing transactions across parallel chains or shards so they can be processed at the same time. Alephium's block flow uses something called a directed acyclic graph, a DAGI structure. Think of it less like a single chain and more like a web of transactions that allows for this parallel processing. It does this on two levels. First, group level sharding. Addresses get put into different groups. Currently there are 4, but it can scale up to 32. Then transaction level sharding. Transactions get processed on specific shards depending on which group's addresses are involved.
So like different highways for transactions based on where they're going, all running in parallel, leading to that high throughput. And let's circle back to that proof of less work thing. How exactly does it cut down energy use so dramatically?
Right, the proof of less work. Pablo W. It's a clever tweak on Bitcoin's proof of work. The goal was directly tackling that energy consumption criticism. What it does is it adjusts the mining difficulty dynamically, like normal PoW. But the key difference happens when the total network hash rate goes above a certain threshold, 1 exahash per second. Once it crosses that line, instead of just demanding more and more raw energy, the mechanism changes. It starts burning ALPH tokens as part of the mining cost. This token burn effectively substitutes a large chunk of the energy cost. The result, under the same network conditions, they claim it uses 87% less energy than classic PoW while still keeping the network secure.
Burning tokens instead of just pure electricity.
Yeah.
That's a really novel approach to sustainability in PoW. Very interesting. Okay, so we have the tech. How is this translating into a real evolving platform? What's happening with upgrades and the ecosystem itself?
Yeah, they've been pretty consistent with upgrades, hitting their roadmap goals. The big one recently was the Roan upgrade in June 2024. That brought some major improvements. Block times dropped from 64 seconds down to just 16. Big difference for users.
Oh yeah, definitely faster.
It also enabled gasless transactions, which is cool, lets you interact without needing ALPH just for fees sometimes. Node performance got an 80% boost in block execution time, and contract storage fees were cut by 90%. Cheaper and faster for devs. Plus, it added new tools for developers, like mapping and multiple inheritance in Ralph.
So Roan made things faster, cheaper, better for devs. Sounds like a solid upgrade. And there's another one coming up.
Yep, the Danube upgrade, planned for 2025. This looks like another big step, especially for user experience and just overall performance. Block times are set to halve again, down to 8 seconds, even quicker confirmations. They're introducing passkeys, which should make onboarding new users much smoother, more like Web 2 logins. And they're getting rid of the complexity of managing which group your address is in these groupless addresses. Should make it way easier for mainstream adoption.
Simplifying the address part. That's smart.
Definitely.
Yeah.
And on the tech side, Danube adds new cryptography, signature types like XKP256R1 and BLS. These improve security and could open doors for easier cross-chain stuff. Developers will also get chained contract calls in EXScript, letting them do more complex actions in one go. And there are general network efficiency improvements, planned better syncing, transaction handling, block flow tweaks.
They certainly seem focused on continuous improvement, not just launching it and leaving it.
Wow.
Okay, beyond the core tech upgrades, what about the stuff users actually interact with? The dApps, wallets, exchanges?
Right, the ecosystem. A good place to start is Alfland. That's kind of their main directory for everything. For wallets, they have their own official ones, desktop, mobile, browser extension. Plus, good news is major hardware and software wallets like OneKey, Ledger, and SafePal also support Alephium.
Good wallet support is crucial. What about trading?
BikeEXs. The two main decentralized exchanges are Awine and Alexium. It's interesting, Alexium has more total value locked, more assets deposited, but AIN actually has higher daily trading volumes, especially for pairs like AlphaUC-DT. And Alexium is notable for being a V33 DEX. That's a model inspired by protocols like Solidly and Olympus DAO, using game theory to really incentivize long-term liquidity provision and token holding. It aligns user incentives quite strongly.
Okay, interesting dynamic there.
Yeah.
And launching new projects.
For launchpads, AlfPad is the main one. They've already run about 10 IDO's initial DEX offerings, including one for Alexium itself, actually.
And NFTs. Gotta have NFTs, right?
Of course, there's an active NFT scene. Marketplaces like DeadRare have seen decent volume, over 180,000 ALPH traded. AlphaGo was apparently the first to bring auction mechanics to Alephium NFTs. And looking ahead, there are always upcoming projects. One getting some attention is AlpBenX. It's aiming to be an over-collateralized stablecoin, using ALPH as collateral to mint stablecoins called ABD with a 150% collateral ratio and liquidation systems.
So wallets, DEXs, Launchpad, NFTs, stablecoins. Sounds like the key building blocks of a DeFi ecosystem are falling into place. Now let's talk about the fuel for all this, the ALPH token itself. What are the tokenomics? How is it designed?
Okay, ALPH, launched with the mainnet November 2021. Hard cap of 1 billion tokens. The vast majority, 86%, is earmarked for mining rewards. That's designed to keep miners incentivized, securing the network for a long time, they estimate around 80 years. And how those mining rewards are calculated is kind of neat. It's the minimum of two things, a reward based on time, which slowly decreases, and a dynamic reward based on the network's hash rate. Keeps things balanced.
86% for mining over 80 years, that's a long-term view. What about the other 14% minted at the start?
Right, that initial 140 million ALPH. So 3% went to the treasury and the team, but it's locked for 3 years with quarterly vesting, keeps them aligned. Another 3% is for the community and growing the ecosystem, locked for 4 years, also vesting quarterly. And the last 8% was set aside for pre-sales and potentially future private sales. Out of that, 62 million ALPH, or 6.2% of the total supply, were sold, and those tokens are scheduled to be fully unlocked by July 2025.
Okay, so clear allocations, vesting schedules for team and community. That seems pretty standard and well-structured. Now, you mentioned deflationary aspects earlier. Token burning.
Yes, and this is quite powerful. Two main deflationary pressures. First, 100% of all transaction fees paid on the network, they get burned, completely removed from supply in every block.
All fees burned, not just a portion.
All of them. And second, that proof of less work mechanism we talked about. When the network hits that high hash rate threshold and switches modes, it starts burning ALPH as part of the mining process. So you've got fees being burned constantly and potentially large amounts burned by Pool W depending on network activity and energy use. Both actively reduce the total ALPH supply over time.
Wow, okay, fee burning and Pool W burning. That creates a really interesting economic dynamic, linking usage and efficiency directly to supply reduction. So wrapping this up, Alephium seems like a really thought-out project. How would you summarize its position?
Well, I think it stands out as this innovative, scalable layer one that didn't just try to reinvent the wheel, but really learned from Bitcoin and Ethereum. It integrated the best of both with that SETXO architecture, and then built on top of that with its own virtual machine, Alfred, and the Ralph language, aiming for a really secure, developer-friendly platform designed for growth.
Yeah, and it's not just theory. Like you said, the sources show they're hitting their roadmap milestones, sometimes faster than bigger projects. They've built the essential infrastructure bridges for stablecoins, hardware wallet support. Oracles are there.
Exactly. It's a functioning ecosystem now. Over 40 projects live, that TVL over $14 million. It's growing. Which brings us maybe to a final thought for you, the listener. Considering how Alephium is deliberately combining these proven ideas, like UTXO, with new solutions for security, for scaling, for sustainability, how do you think its unique approach might influence how other layer ones are designed in the future? Especially as we see more and more demand for dApps that are efficient and secure. What part of Alephium's strategy stands out most to you in tackling those big, persistent blockchain challenges?